Hey guys, I just wanted to make sure that I put this video in. I'm sorry I forgot it earlier. Here's the idea of properties of logarithms. It's very much like exponential properties, so you probably already know them, but you didn't know it in this type of form because logarithms are just an extension of exponents, right? It's that exponential form written a different way. So the properties are very much the same. There's something called the product property. It's written right up here. It says that if you have a log that's a certain base and you have a little multiplication here, that you can take these and turn it into addition. And what that really looks like is this. If you have 3 to the 6th power and 3 to the 4th power, because they have the same base, we just add these exponents together, and this is the same as 3 to the 10th power. All right, this is actually the same thing because remember, logs are written in a different way, right? So the x and the y are actually your exponents, and they're being added together. We're just using logarithmic form to do that. The same thing holds true with the quotient property. The quotient property is written right here. We say 3 to the 6th power over 3 to the 4th power is the same thing as 3 to the 6th minus 4, which is 3 squared, right? So it's the same thing, it's just written a different way. The only thing that might be new, is this power property. It looks different, right? But when we have 3 to the 6th power, and that's in parentheses, right? This is our power property, right? We've raised it to a power of 4, so that's 4 of these 3 to the 6's, so it would be 3 to the 24th power. Well, this is kind of the same thing, only we take this power and we throw it up front in the log, and it basically does the same thing to that power. Now, since it looks different, it might feel a little bit different, but we'll go ahead and use that power to our advantage in solving some of these things. And I'm going to show you how these powers come into play when we're trying to evaluate a certain set of logarithms. This first example says evaluate 3 log base 2 of 8 plus 5 log base 2 of 1/2. Now, we could do a couple of things, right? We can go ahead and rewrite this 8 as 2 to the 3rd power. That helps us out a little bit, and it's going to help me teach you one last piece of the puzzle. And then we know that 8 is 2 to the 3rd, and that's what they wrote down here, right? And we know that 1/2 is 2 to the -1, right? Anything to the -1 power becomes a fraction with this as its denominator. And if it was -2, it would be 1/4. Anyway, that's the way it's written, so we rewrite it that way. And then the last thing that they did, I'm trying to see if there was anything cool that they did. No, they didn't. They left everything alone, right? All they did right here for our wonderful example was put everything in base 2 land, right? It makes everything so much easier. And here's the last thing that I get to teach you. Anytime you have a log base 2, and it's a log base 2 of 2, even if it's 2 to some power, this log base 2 of 2, right? This just becomes 1. Right? So anytime your base is the same as this value right here, that just becomes 1. So here's what we've done. We've just created an identity here. There it is. We know that this exists in the world. I know I shouldn't use the word identity, but to me, I just want to make sure that it's that property that shows log base of something. If the base and that something right there is the same number, then we have created 1. What did they do? They showed it down here. There's the 1, there's the 1, right? So what's left over? The 3 up front, the 3 which is a power, and this 1, okay? What's left over? The 5, right? The negative 1, and this cancels out. Anyway, do all this math, you come up with 4. Sometimes you just have to rewrite. Sometimes you just have to expand. You don't have to evaluate, or you may not be able to evaluate. Sometimes you just have to expand something that looks like this. All right, expand this, the natural log of 8x to the 5th over 3y squared. All right, well, we can't solve anything. We have an x and a y, and we don't really know how to expand that, right? But we know that all we have to do is rewrite this in log form, and they're using the natural log for this. You can use the common log for this if you want. Either way, it works out just fine. So, the natural log of 8x to the 5th, right, minus 3y squared. We just rewrote it. This is multiplication here, so we're going to expand this even more. All right, so the natural log of 8 plus the natural log of x to the 5th, we've got a little bit more work to do, minus natural log of 3 minus the natural log of y squared. And we see if we have powers, we have a little bit more work to do. That power property says we're going to rewrite that natural log of 8. We're going to rewrite this as 5 natural log x minus natural log of 3 minus, because remember, we're splitting it up and we distribute the negative, natural log of y, put the 2 in front. All right, so that's really how it works. We're going to do probably, yeah, this should be pretty good. Let's do this example right here, this exercise right here. We're just going to evaluate this log. And what I want is if I have a log base of 3 and a log base of 3, I want to make sure that what I put next to it is has a base of 3, right? I'm looking for a base of 3. I know that 27, by the way, is 3 cubed, so I'm going to rewrite that. Pardon me. So I'm going to rewrite 2 log base 3 cubed, because this is 3 cubed, right? And then we're going to add to it 4 log base 3. And this 1/3 here is just like that 1/2 in the previous problem. It's just 3 to the negative first, or 3 to the negative 1. Now, we know, because I've told you, but I want to remind you, that if we have a log base 3 and a 3, these two things equal 1. All right? So we have it here again. We're just trying to get these logs out of our way so we can do some evaluation. What's left over? A 2, a 1, and a 3. So 2 times 3, I don't even want to write the 1 down there, plus 4 times negative 1. And if we evaluate this, we get 6 plus negative 4, which equals 2. Sounds pretty good, right? Other than that, we can just expand. This is expanding using both the quotient property here, and we also have some multiplication and some powers that we have to reconfigure. Let's go ahead and do that one. I'm going to lift this up. Maybe I'll blow it up a little bit so I have more room to work, because it is one of those things. There we go. All right, let me erase. Let me jump right in here. First things first, we're going to just expand this using the quotient property. The quotient property says if I have division, I can rewrite it as subtraction. So I have log base 3, 5r to the 5th, minus log base 3. Now we have the cube root of t squared. The cube root of t squared. Now, none of these, we can't find something that's base 3 because we have a 5 here and an r5 here, but this can be expanded some more, right? So I want you to realize just a couple of things. This cube root, sorry, I forgot the cube there. This cube root can be written as something different, and this can be expanded a little bit. So this is, we use some addition here, log base 3, 5, plus log base 3, r to the 5th. Now we're going to use the power property later, but we're going to subtract from it log base 3. Now this right here sort of helps us. We know that the cube root is really just a power of 1/3. So I'm going to rewrite that as t 2 times 1/3, which is actually just 2/3. There we go. So I'm just going to rewrite it as 2/3. And then we can take our powers and put them up front. And we say log base 3 of 5 plus 5 log base 3 of r minus 2/3 log base 3 of t. And that's really it. There's some problems where you get to condense them, you move the power back, etc., and then just condense it. This would be the quotient property. Just keep looking at it. Of course, as always, if you have any questions, please contact me. I'm always available.